Hello all. As I said many times in previous videos, sometimes you get fed up when you work with physics papers and physics equations. So I took a break by doing the ranking of physics equations video, and today I decided to do another one on Universe Sandbox. Okay, so for those of you who don't know, this is a simulation game. Okay, I'm sorry. I'm zooming in and out. That's why you saw a bright sun. So this is a simulation game that simulates, as far as I know, the solar system. I've been I've been meaning to buy this game for at least a few years, and I finally got around to buy it a few months ago. But I didn't really play around with it. I don't know. Maybe I'm too old for gaming, and it's not even gaming. I mean, this is a simulation. But for one reason or another, I never really found time for it or interest or whatever. But anyway, this is it. This is what you see when you open the game. Oh, for those of you who are interested, and I'm not being sponsored by them, I wish I was. The game costs 30 euros, and I think it's $30 in the US, Canada, and so on. So, it's a one-time buy, and you buy it, and that's it. And you also have to download that. I forgot the name. Gamers know that it's a kind of a popular thing, but I forgot now. Anyway, it's a platform that allows you to play various games, and you launch Universe Sandbox through that platform. So you see how little I know about it. So anyway, so this is the menu. The computer fan is running crazy, which means that I have to change some settings probably, because maybe the simulation is too heavy on the computer. So let's see, settings. Okay, and as you can see, this is one of the first times I play this game, so I don't really know much. So we're gonna discover things together. So okay, the startup simulation is the solar system now, but it can also be the Earth and the Moon. Okay, let's do this. And will it take us there though? If we exit, we will see. Okay, anyway, so let's start with that. Let's see what's happening with size. Okay, mode, maximize that. Let's do full screen. Okay, maybe that's better. HDR, no. Quality, render scale. I guess this is the render of the simulation. Anti-aliasing, okay. Performance, maybe this, okay. Surface simulation resolution, medium, high. Let's do medium, okay. Changing the surface simulation resolution will restart the simulation. Okay, restart. Okay. Simulation performance high. Let's do medium. Okay. And maybe let's take this back to medium high. Okay, restart. All right, so anyway, these are the settings though. I mean, there are many other things you can change, but anyway, let's go back. And okay, if you go here, you can start a new empty simulation, open existing simulation. Okay, let's do that. Okay, these are all the simulations, I guess. Let's do, okay, what's this? Physics, okay. Saturn and Earth. Earth and closed moon tightly locked. No. Okay, let's try this. Earth at 1000 degrees. Right. So 1000 degrees is roughly the temperature of what? Lava. What's that? Of lava. Yeah. What am I saying? Lava. Yes. Heat the Earth to this temperature, and its surface will begin to melt. As the ice caps melt, water vapor fills the atmosphere above the boiling oceans. Meanwhile, the Earth slowly cools as its heat is lost into space. And this is radiative heat, guys. I mean, remember the Stefan Boltzmann equation about the luminosity of an object at some temperature. So the luminosity will increase, but this way the Earth will lose temperature. Okay, so what can we do? How do you play this? So okay, simulation: gravity on, collisions on, fragments on, temperature on, object count, attracting. Okay, can we do tools? Material, modify, powers, explore, capture. Okay, I don't know. There are too many options in this game, so it's a complicated game. If you do sim, can you add? Okay, let's close that. Okay. Okay, maybe if you press plus. Okay, we can add, I guess, something. So it added the moon. Okay, let's add another moon. It added the moon because the moon is selected. Let's add Phobos, which is one of the two moons of Mars. And the scale here is 100,000 kilometers. Okay. Wow, this is really nice. Okay. How far away is the moon? I should know these kind of things. It's about a few 100,000 kilometers. Maybe I want to say 200,000. So let's put Phobos there. Okay. Okay, and let's close this. Where's the Earth? There. Okay. And how do you start the simulation? Transform, no. Simulate. Do you just press play? Okay. Okay, you press play and see what happens, I guess. And that's Phobos. Okay, so can we accelerate this? Let's see. Yeah, okay. Wow, okay. So the moon is stable there, actually. Okay, let's slow this down. By the way, you see that you can change, so 5.7 hour per second is the rate at which the simulation. So 1 second is 5.7 hours. This is what it means. So now 1 second is 9 hours. So now 1 second is 1.8 days. So the moon goes around the Earth in less than a day in this simulation. Okay, that's crazy. Okay, what if we increase G? Can we? Let's do it by 10. Wow, it exploded. Everything exploded, actually. The moon fell on the Earth. Okay, so can we stop this? Yes. And how do you reset? Okay, maybe we can go back here. Let's go back and let's start a new empty simulation. Okay, perfect. Now let's add objects. Do you want the Earth? Maybe we should add some stars. Betelgeuse. Okay, let's add Betelgeuse somewhere there. Okay. By the way, notice that how large is it? 6 AU is the radius, it seems. No, that's the cursor. Anyway, so okay, let's see. By the way, it's way more fun if I was sitting here alone just playing with it. I would get bored. But now because I have to talk about it, because I'm assuming that someone is watching and someone might actually find this interesting and want to try it on their own, I put more effort and I find it more fun. So anyway, so let's add the Earth. Let's add the Earth at 21 astronomical units away. Okay, recall that the Earth is 1 astronomical unit from from the sun, okay? And the Betelgeuse is a high luminous star. I don't remember the luminosity, but it's higher than the sun. Okay, let's put it at 43 AU and see what happens. Okay, let's close this. And if we did things correctly, it should be running, right? Okay, so how can I fly to the Earth? Okay, so this is the Earth. Okay, let's increase the simulation time. Okay, you see that the Earth is going around. Oh my God, it's cooling down. Okay, you see there what's going on. Okay, let me see. Okay, motion, surface. Okay, it's really hot in the middle and cold. Okay, so it seems like yeah, we fried the Earth. Okay, the Earth is dead in this simulation. Oh, okay, it's there. So the average temperature is 525 degrees Celsius. The minimum temperature is minus 273. That's the absolute zero. And the max is 630. Okay. What other information do they give us? Okay. Infrared emissivity, okay. Okay, composition, visuals. Okay, so the Earth will die if it's just, what was it, 36 astronomical units. So anyway, I didn't mean this to be a long video. I just wanted to start playing with this. This is the first time I'm actually doing this. Okay, this is really interesting. Okay, I will, if any of you wants to see any kind of simulations, let me know. I mean, we can try some of the stars we see at the A-level physics tests, for example, or anything else you might find interesting. So just write me in the comments and I might film another video. So, but anyway, I meant this to be short, so I will stop it now.